Name the process in step 1, step 2. We said step 4 is combustion, step 1 is oxidation, step 2 is dehydration, and step 5 is polymerization. Step 3 is esterification. So therefore step 1 is oxidation, addition of oxygen. Step 2 is dehydration, removing of water. That's what it means. Write equation for step 3. Step 3 is esterification. So we write the equation of esterification, that is step 2, that is C2 ethanol, which is reacting with, you can see, ethanol plus 2 ethanoic acid. Ethanol plus ethanoic acid, we are going to form ethyl ethanoate. So plus ethanoic acid, we form plus water, and this one is called ethyl ethanoate, and it is an ester. This is an ester, and the process is esterification. Write the chemical equation for the formation of substance Y. Substance Y is the ester, and we have done that. So the one we have done is the same, so this one we repeat it here, and that is all. The equation for the formation of Q. So we go to substance Q. Substance Q, it is the combustion of ethanol. When ethanol is an organic compound, when it burns, it forms carbon dioxide and water. So gas S is carbon 4, liquid Q is liquid water, the water. So you should know that. Now ethanol plus oxygen, it burns to give us CO2 plus water. Carbon here, there are 2 of them. We balance that like that. So 2 carbon. Hydrogen here, there are 5 plus 1, 6. Here there are 2, 3. So there are 2. So 2 times 3 will make 6. In the process, oxygen atoms here, there is 4. 4 plus 3, 7. Here we have 1, 3. So if we multiply by 3 here, we will have 6 plus 1, 7. And that is all. Status, this one is a liquid, a gas, liquid. Formation of K. Formation of K. K is ethanol reacting with undergoing oxidation. So that one is simple. So ethanol C2H5OH in the presence of it's acidified, so it forms ethanol, ethanoic acid, CH3COOH. Oxidation. Formation of gas S, that is combustion. It is the same gas. Gas S and Q are formed at the same time, so this one is actually this. Here is another question. Study the flow chart below and answer the questions that follow. So first, before even you go to the question, analyze this flow chart. Know every step, the name of every step, what's happening before you go to the question. So let us start step 1. Step 1, what's happening? First, what is this? This is a double bond, therefore 1, 2, 3. This one is propene. This is propene. So propene is undergoing step 1, forming propane. Yes, this one is propane. So what is that? So step 1 is hydrogenation, addition of hydrogen in the presence of nickel catalyst. So that's the thing. Now propene is undergoing step 3 and it is forming a polymer. We know this one is a polymer, right? Therefore, this one is polymerization. So we know step 3 is polymerization. Let us go to step 2. So propene, how was it formed? It is formed from 1, 2, 3 ethanol, OH from ethanol. So we are forming this. So in step 2, what happens when ethanol is forming propene? The water inside it is removed. So step 2 is dehydration, removing of water to form propene. Propanol, water in propanol is removed to form propene. Ethanol is reacting with potassium in step 7 to form liquid X plus gas M. That is okay. Step 5, ethanol is reacting and is forming propanoic acid. That is oxidation. Remember, oxidation requires acidified potassium permanganate. Acidified potassium permanganate. Acidified potassium permanganate from that. The next thing, so here, how was this ethanol formed? Ethanol was formed from sugar. So remember how ethanol is formed. And remember, this one is propanol, but whether it is propanol, pentanol, whatever it is, it can be formed from sugars. Therefore, propanol is formed from sugar. Which step is this? This step we know it is called fermentation, where sugars are hydrolyzed. That is, sugars undergo decomposition using the yeast the enzymes to form alcohol. Now propanoic acid in step 6 is reacted with conc sulfuric acid plus ethanol. It forms L, and L, whenever you see this propanoic acid and ethanol in the presence of sulfuric acid, that one is esterification. Esterification. So this one is an ester. L is an ester. So you see, we have did the analyzation. So once we go to the questions, you will just be picking the answers from here. Thank you. So let us go straight to the questions. So the questions here have a total sum of 11 marks up to here. So in fact there are 12. There is another question on the other side. So make sure you score all of these marks in organic chemistry. So question 1, name the type of reaction. Name the type of reaction in the following steps. Step 3, step 4. Step 3 and step 4. So we go back to the chart and then see step 4. What kind of reaction do we say is there? The reaction in step 3 is polymerization. The reaction in step 4 is fermentation. So these are the things we are going to write there. But remember, we have two types of polymerization. We have addition polymerization and condensation polymerization. This one is addition. Therefore, the correct answer for the reaction taking place here is addition polymerization. Addition. So this one is addition polymerization. Step 3 is fermentation. Name the important reagents and conditions in step 1, step 2, step 4. So we are looking for the reagents in step 1, step 2, and step 5. Step 1, step 2, and step 5. So you go back to the chart and then step 1, it is hydrogenation. So the reagent is hydrogen. The reagent is hydrogen. And then the condition is that we must have a nickel catalyst and a temperature of 150 to 250. Remember that, 150 to 250 temperature. So those are the conditions. The reaction in step 2, where is step 2? Step 2. here. Step 2 is dehydration. We did that. Dehydration is the removing of water, therefore it requires concentrated sulfuric acid. Dehydration requires concentrated sulfuric acid and a temperature of 160 and 180 degrees Celsius, between 160 and 180 degrees Celsius. Step 5. Step 5, it is oxidation, and oxidation requires acidified potassium permanganate. Because it is acidified, so we use a sulfuric acid and potassium permanganate. So the reagent is potassium permanganate. The condition is that we need sulfuric acid because we need the acid to be acidified. So this is the process, is hydrogenation, and we need hydrogen. And then temperature, the condition is temperature of 150 degrees Celsius to 250 degrees Celsius in the presence of nickel what? Nickel catalyst. Nickel catalyst. The presence of nickel catalyst. Step 2, we have said it's dehydration. Dehydration, the reagent is concentrated sulfuric 6 acid. The condition is temperature of 160 degrees Celsius to 180 degrees Celsius. Step 5, we said it is oxidation. Oxidation, the reagent is acidified, actually because of the acid, it is potassium permanganate 7. The condition is that we need sulfuric acid. Sulfuric acid, it should not be, it's not a must for it to be a conc. Sulfuric acid, sulfuric 6 acid is required to make this potassium permanganate acidified. So those are the conditions required there. Write a balanced equation for the reaction taking place in step 6. Step 6. So we'll go back to the chart and see step 6 what is there. So step 6 is here. It is the formation of an ester. So propanoic acid plus ethanol. Very good, to form an ester. So we are going to react propanoic acid plus ethanol to form an ester. So propanoic acid is CH3, CH2, COOH, that's propanoic acid, and then plus ethanol, CH3, CH2OH, which will react in the presence of sulfuric acid. A few drops of sulfuric acid, it will form ethyl 1,2, CH3, CH2, and then C, OO, and then this one now combines it there, which is CH. We can combine it 2C, and how many hydrogen? 1, 5, and then plus water. So this one is called, anyway, we have not been asked to give the name, but it is called ethyl 1, 2, 3 propanoate. Ethyl propanoate, that is the name of that. Step 7, the reaction in step 7 is where ethanol is 1, 2, 3 propanol. Propanol is reacting with potassium to form the salt, organic salt, plus hydrogen gas. Gas M is hydrogen. So C2, CO3, that is H7OH. I have shortened ethanol plus 2K. We have 2 here. We form C3, H7OK. This one is called potassium propoxide plus hydrogen gas Liquid X is potassium propoxide, substance H, which is the ester. The ester is called ethyl. This ester here, ethyl propanoate. Ethyl propanoate, that is the name of the ester L. State 2 chemical test used to differentiate between alkane and an alkene. So this one is propane and propene. How can you differentiate between propane and propene? Propane is an alkane, propene is an alkene. Remember, alkenes are unsaturated, while alkanes are saturated. I don't know whether you know how saturated alkanes what they are and unsaturated what they are. But now I'm going to differentiate. We have been asked two chemical ways or to differentiate between alkanes and alkenes. So the first thing you should know is that, because now this we are talking about specifically, we are going to use acidified potassium permanganate or bromine water. So we are going to say that this one, C3H8, which is an alkane, or we start with 6, an alkene. CH3, which is an alkene, will decolorize bromine water. Bromine water will decolorize bromine water or acidified potassium permanganate, which is purple. It will be decolorized. But C3H8 will not. So alkene will decolorize bromine water, but alkane will not, because alkanes are saturated, alkenes are unsaturated. The next test is burning. When alkenes are burnt, they burn with a yellow sooty flame. When alkanes are burned, they burn with a blue non-sooty flame. That's another way you can differentiate them. Therefore, C36 burns with a yellow sooty flame, while C3H8 burns with blue non-sooty flame. So by burning that, you can differentiate it like that. If the relative molecular mass of a compound formed in step 3 is this, determine the value of N. So let us go to compound step 3 and see the compound that was formed. Step 3 is addition polymerization. So this one is a monomer. So we are going to calculate this one monomer. So N is missing here. This one monomer. So we are going to add this monomers 1, 2, 3, 36. 36 plus 6, it is 42 N. Therefore, our monomer is CH3. CH double bond is CH2. So get the 1, 2, 3. We have 3, 2, 1, 2, 3. 3 carbons times 12, each is 12, and then plus 3, 6 hydrogen times 1. Everything times N will give us 42,000. So this is 42N. 36 plus 6 is 42, is equal to 42,000. So it means that N equal to 1,000. So the monomers which will form a polymer with a molecular mass of this we will need 1000 monomers. State one disadvantage of continued use of items made from compound formed in D above. The compound formed in D Roman 1 is a polymer. What are the effects of polymers? Polymers, they cause pollution. The compounds formed there, they are called polymers, and they cause pollution. Why? Because they are non-biodegradable. So you say the compound formed are non-biodegradable. They don't decompose. Polythene papers, polythene things, that's why polythene papers were banned, because they don't decompose. Therefore, continued use of these items of polymers is going to pollute the environment, because the compounds don't disintegrate. They are non-biodegradable. Thank you for this lesson.